Welcome, focused learners, to another explainer. Look, I want you to picture something for a second. Imagine the exam hall. You know the feeling, right? It can honestly feel like a desolate wasteland straight out of a movie. The clock is ticking down relentlessly, the pressure in the room is absolutely mounting, and you are sitting there trying to navigate this vast, tricky landscape of Cambridge computer science exam questions. It can feel like absolute survival mode out there, especially when you turn the page and see a massive 12-mark evaluation question staring right back at you. But listen to me. Today, we are not just going to survive. We are going to claim your grade treasure. Welcome to the Mad Max Fury Road to your A-star. Today, we are undertaking a high-level masterclass completely decoding the Cambridge Information Technology syllabus. Specifically, we are zeroing in on topic 3.2, moisture, pH, gas, and infrared sensors. Now, whether you are tackling the IGCSE codes like 0417, 0478, or 2210, or you're stepping up to the heavyweight A-level papers like 9618 and the beast that is 9626, the strategy we are unpacking today is your ultimate survival guide. I am genuinely thrilled to guide you through this, because mastering these specific sensors is without a doubt the ultimate test of your analytical skills. We are going to completely transform you from a survivor into a conqueror. So let's go up, get focused, and get started.
So, we have to start with the ultimate question. What truly actually separates a B grade from an A star in topic 3.2? To understand this, I want to introduce you to two typical students we see wandering the exam wasteland all the time. Let's call them Alex and Sam. Now, Alex is a hard worker. Alex has read the textbook cover to cover and overloads the exam paper with raw, unfiltered computer science facts. If you ask Alex a question about a pH sensor in an agricultural setting, you will get a beautiful dictionary-perfect definition of acidity, alkalinity, and hydrogen ion concentration. But you'll get absolutely zero analysis of the specific scenario provided in the question. None. It's just a massive data dump. Sam, on the other hand, has a different problem. Sam rushes. Sam is terrified of that ticking clock. When Sam sees a complex question about an infrared sensor being used in a smart security system, panic sets in. Sam completely misses the command word requirements at the start of the prompt, words like evaluate or justify, and ends up writing a really brief, panicked summary that barely scratches the surface of what the examiner is actually asking for. Here is the harsh truth. Both of these students have knowledge, but neither of them is securing that A star. The difference between a B and an A star isn't just about what facts you have memorized. It is entirely about exactly how you structure, how you analyze, and how you present that knowledge when you are under immense pressure. It's about playing the game by the examiner's rules. All right, here is our survival map for today's masterclass. First up, core sensor principles. Second, the procedural framework. Third, critical analysis tactics. And finally, top examiner warnings. Let's keep moving. Part 1, Core Sensor Principles. Let's lay down the theoretical foundations. Okay, look closely at this matrix. Top-scoring candidates, the ones pulling the A stars, they do not just memorize flat definitions. They map out cross-topic connections to achieve significantly higher marks. Think about moisture, pH, gas, and infrared sensors. An infrared sensor doesn't just, detect heat. That's a middle school answer. In a cross-topic Cambridge scenario, an IR sensor triggers an analog-to-digital conversion, feeds that digitized data into a microprocessor, which then compares it against preset values, and ultimately initiates a program security protocol like sounding an alarm or locking doors. It's a chain reaction. Similarly, if you consider a gas sensor, it is intrinsically linked to complex environmental monitoring scenarios, requiring data logging and threshold triggers. To unlock these deep connections and secure those top-tier marks, examiners use specific command words, words like evaluate, analyze, or compare. And how do we conquer these command words? We use the PEEL framework. P-E-E-L, point, evidence, explanation, link. This framework right here is the structural chassis of your A-star answer. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Now, this slide brilliantly illustrates exactly what Cambridge means when they talk about conceptual understanding. It is all about demonstrating logical, structured reasoning that is transferable to entirely unfamiliar contexts, prioritizing analytical depth over superficial breadth. Remember Alex from earlier, the student who wrote a novel of random facts? That right there is superficial breadth. The examiner sitting there with a red pen does not want 10 random facts about moisture sensors that you memorized from a flashcard. They want you to take the core principle of a moisture sensor and apply it to a totally unfamiliar context. Say, an automated smart irrigation system inside a futuristic vertical farm. You have to prioritize analytical depth. This is where PEEL saves your life. You make a clear point about the sensor's role, you back it up with evidence pulled directly from the text of the scenario, you provide an explanation of the technological interaction, how the sensor talks to the ADC and the microprocessor, and finally, you link it back to the overarching goals of the system, like conserving water or maximizing crop yield. That, my friends, is logical, structured reasoning in action. That is how you dominate.
Moving on to part 2, the procedural framework. This is where theory meets the paper. Okay, this is absolutely critical. You have to follow these 5 steps rigidly. Do not skip them. Step 1, deconstruct the question. You literally take your pen and highlight the command words and the specific sensor type. Step 2, extract relevant data. If the paper gives you a scenario about a pH sensor in a chemical plant, you comb through that text and pull the specific acidity thresholds they mention. Don't invent your own numbers, use theirs. Step 3, select your analytical framework. And as we established, 9 times out of 10, you are going to deploy the Peel structure. Step 4, execute with clear notation. Step 5, present with correct terminology. Let's actually do a live rewrite for our student Sam. Remember Sam, who rushed a 6-mark question on why an infrared sensor is used in a burglar alarm? Sam got 0 marks originally. Let's fix that. Using our framework, Sam first deconstructs the justify command word. Then, applying Peel step by step, Sam writes, infrared sensors are the optimal choice for the security system. That's the point. The system relies on detecting human body heat variations against ambient room temperatures. That's the evidence from the scenario. Because IR sensors detect these specific thermal radiation changes instantly without emitting visible light, they provide stealthy, immediate analog signals to the ADC and microprocessor. Boom, that's the explanation. This makes them highly reliable for covert intrusion detection compared to standard, easily bypassed motion sensors. And there is the link back to the question. Did you see that? That answer just completely transformed from a 0-mark rush job to a full marks A-star green checkmark? This is your ultimate computer science success blueprint.
Now, you might be thinking, as long as the information is there, I'll get the marks, right? Wrong. Examiners are incredibly strict about the professional presentation of your information. If you read the principal examiner reports, which you should, they explicitly state that practical application in Topic 3.2 is meant to develop professional skills. This means applying correct formats, using highly appropriate technical terminology, and providing clear annotation. If a question asks you to design a data logging table for a gas sensor that is monitoring air quality over a 24-hour period, you cannot just lazily draw a sloppy, unlabeled box on the page. That's literally bleeding marks. You need proper professional headings like carbon monoxide parts per million, you need to use correct terminology, and you need appropriate formats for time and date values. The examiners are basically looking for you to step into the role of a real-world IT professional. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @aceexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @aceexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's dive into part 3, critical analysis tactics. Time for the interactive workshop. A basic B-grade answer relies heavily on superficial breadth, but a top-tier A-star answer demonstrates advanced evaluative thinking. It does this by questioning assumptions, considering different perspectives, and constantly justifying decisions with hard, scenario-based evidence. All right, it is time for Challenge 1, the data scan. I'm putting a 60-second timer on the clock in your head. Imagine a complex data table right in front of you. It is detailing soil moisture percentages and corresponding pH levels in an agricultural field over a 24-hour period. I want you to extract the core trend. What is the data telling you? A B-grade student just reads the numbers back to the examiner. At 10 a.m., moisture was 15% and pH was 4.5. That gets you practically nothing. But using our top-tier tactics, you scan that data and you should instantly notice a pattern. As soil moisture drops below the 20% threshold, the pH level becomes highly acidic. If you extract that inverse relationship and then explain how a microprocessor uses that dual sensor data to automatically trigger an alkaline irrigation release to balance the soil, wow, now you are thinking exactly like an A-star candidate. You are justifying your automated system design with evidence drawn directly from the data scan. This brings us perfectly to the absolute secret formula for writing a comparative analysis. When a question asks you to evaluate or compare different sensor performances, it is never enough to just list their features side by side. You need to present similarities and differences, and they must be linked by comparative connectives, ultimately leading to a solid conclusion. Let's test this with Challenge 2, Find the Flaw. I want you to listen very closely to this sample paragraph and tell me exactly where this student is losing marks. Ready? Here it is. Both moisture and pH sensors are used in agriculture. Moisture sensors measure water content, while pH sensors measure acidity. Therefore, moisture sensors are better. Okay, time's up. Did you catch the flaw? The fatal flaw is in the conclusion. If we look at the examiner commentary for an answer like this, they would note that this student used absolutely zero comparative connectives, words like whereas, conversely, or in stark contrast. Worse, they drew a completely unjustified conclusion about relative importance without a shred of evidence. Better for what? A top-tier comparative analysis must weigh the specific context to determine which sensor is more critical for the given agricultural outcome. And this naturally brings us to a massive examiner alert, something that catches so many students off guard. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. Listen to me carefully. In Cambridge Computer Science and Information Technology papers, the process earns points even if your final calculation or logical deduction falls slightly short. Let's test this right now with Challenge 3, speed writing. We're going to do a rapid-fire mental exercise. You have 30 seconds. In your head, I want you to structure one perfect peel paragraph explaining exactly why showing your working is vital for a gas sensor calibration question. Think about it. Go. Okay, time, let's break it down. You should be noting that the point is securing method marks. The evidence is the examiner rubric itself, which allows for partial credit. The explanation is that laying out your step-by-step logic demonstrates a conceptual understanding of the sensor's calibration process, even if your final arithmetic is totally flawed. And the link is that this systematic, transparent approach guarantees partial credit, saving your grade. If you structured your mental paragraph anything like that, congratulations, you're mastering the system.
Finally, Part 4, Top Examiner Warnings. Let's fortify your strategy.
The crucial point of this final section is avoiding what the grading teams call the 3 fatal flaws. Flaw number 1, answers regarding moisture, pH, gas, and infrared sensors are entirely too vague. You cannot just write, "the sensor detects things." Examiners despise that. They want specific technical details. Exactly how does the infrared sensor detect thermal radiation? What is the specific chemical reaction or resistance change the gas sensor is measuring? Flaw number 2, forgetting format and presentation. We covered this earlier. Headings, tables, professional formatting. If you ignore it, you are throwing away easy marks. But flaw number 3, this is the biggest one, the absolute grade killer. Answers are not specific to the given context. Listen, if the exam question is about implementing a gas sensor in a hazardous underground mine, you cannot give a generic, rehearsed answer about how gas sensors work in a domestic kitchen for a fire alarm. You just can't. You must reference the specific toxic gases relevant to that mining environment, like methane or carbon monoxide buildup. Your answer, your explanation, and your evaluation must be entirely locked into the exact context provided on the paper. So how do we make sure you never fall victim to these fatal flaws when the pressure is on and the clock is ticking down in that exam hall? I am going to give you a highly actionable study technique, a cheat sheet for your brain. You need a memory hack to recall the specific factors that affect the performance of these sensors. Let's use the acronym SPECS. S stands for sensitivity, exactly how slight of a change in the environment can this specific sensor detect. P stands for placement. Where is the sensor physically located in the scenario context? High up? Buried in the soil? E stands for environment. What are the extreme conditions, like massive heat, humidity, or dust, that might be affecting the sensor's accuracy? C stands for calibration. How often does the sensor need to be reset to a baseline to remain accurate? And finally, S stands for sampling rate. How frequently is the microprocessor actually pulling and reading data from the sensor? Every second? Every hour? Memorize SPECS. When you open that paper and face a brutal 12-mark evaluation question on a pH sensor, filter your entire answer through sensitivity, placement, environment, calibration, and sampling rate. It guarantees your answer will not be vague, and it forces you to deeply engage with the specific context. So I leave you with this final critical question. Will you let vague context cost you your A star? You don't have an excuse anymore.
We have given you the complete ultimate answering system today. You now know exactly how to decode the command words, you know how to relentlessly apply the Peel framework, and you are armed with the SPECS memory hack to guarantee depth. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Practice these strategies with past papers, and you will absolutely transform your results. The exam wasteland doesn't have to be intimidating when you have the right tools. Keep evaluating, keep analyzing, and go claim that grade treasure. See you next time.